this is homework 10, and let's look at the first problem, the Poisson process, which is defined as the parameter lambda t. So the probability p and t1, t2 equal to k equal to so this expression means during the time interval t1 to t2, the points shown in this time interval, the sum of these points. So we can use this expression to calculate. So this is the first property of the Poisson process, and the second one is the given the time interval t1, t2, t3, t4, if these two intervals are non-overlapping. So when t1, t2, and t3, t4 are independent. So this is the second property, and it has the expectation E xt equal to lambda t, and the autocorrelation this one. So with the sketch, so this is the Poisson process, and let's look at the normal process. Normal process given the process xt, so it is normal if x t1, x t2, x tn, these processes are jointly normal for any n t1, t2 to tn. So the normal process can be determined by two parameters. The first one is the eta t, and the second one is c t1, t2. So its expectation ex t equals to eta t, and so with these two parameters we can determine the normal process. Let's look at the second problem. The y is a stationary process. The Wilson stationary process satisfies the process has the expectation ext equals to a constant, and ext plus tau equal to Rx tau. So its auto correlation is just depend on the time interval t1 minus t2 equals to tau. So this is the wide sense stationary process. So this means given a wide sense stationary process, it doesn't process itself doesn't change by the time shifting. So we can have some examples such as the noise and the voltage. So this is the wide sense stationary process. And the second one is the independent increment. Given the increment xt minus xs, so xt1 minus xt0 and xt3 minus xt2. So these increments are independent. So this is an independent increment, and the third one is Markov process. So it is defined with the conditional probability P xtn equal to xn under the condition xt1 equal to x1 xtn minus 1 equal to xn minus 1. This one equal to pxtn equal to xn under the condition of xtn minus 1 equal to xn minus 1. So this expression explains that the process xt doesn't depend on its former time of the process. So this is a Markov process. Let's look at the fourth one, the strict sense stationary process. So this process is defined with the process xt1, xt2 to the xtn, and xt1 plus h, xt2 plus h, xtn plus h. So these two series of the process has the same distribution. So we can call this the strict sense stationary process, and we can make a conclusion that the wide sense stationary process is a subset of the strict sense stationary process. And let's look at the last one, the white noise. The white noise, we see that it is a process, and its value v ti and v tj are uncorrelated for every ti doesn't equal to tj. So we can make a conclusion that CTI Tj equal to 0. with Ti doesn't equal to Tj. And the autocovariance of a non-trivial white noise process must be the form of the C T1 T2 equal to Q T1 delta T1 minus T2 and Q T must bigger than 0. So this is a definition of the white noise.